What's going on, guys? Welcome to LetThereBeMath again, and in today's video we're going to be talking about how to integrate a binomial function like the one we have here. So here we're going to take a and b to be any constants we choose, and n is going to be any power we choose as well. Now the idea behind this is that we're going to start off by looking at the derivative of this function. And this is something that I recommend you do every time you're looking at a new integral and you don't know how to do it. We're going to grab the same function, we're going to differentiate it, and hopefully that's going to reveal some clues as to what we need to do. So let's start off with the derivative of this function. We're going to look at the derivative of ax plus b to the power of n. And we know that to differentiate this function, we're going to apply something called the chain rule. Now the chain rule tells you that if you have any function like this one, so let's say we're differentiating a function u that is in itself a function of x. So here we have a function inside a function. The chain rule tells you that you're going to first of all differentiate the function u with respect to the inner function df, and then you're going to differentiate the function f with respect to the innermost argument, which is x. And we can extend that same concept if we had even more inner functions in them. So here what we're going to do is we're going to assume that the function x is going to be the linear part, which is ax plus b, and then the function u is going to be the nth power of that. So the function u is instead going to be f of x to the power of n. So that's how we're going to phrase this problem. So now if we go ahead and follow that chain rule differentiation formula here, we're going to start off by differentiating u with respect to the function f. So if we look at it this way, if f is treated as a variable in itself, we're going to bring the power n down. That's going to be n times the function itself, which is ax plus b, and then we're going to decrease the power by 1, which is going to become n minus 1. And the last thing we want is we want to differentiate the inner function f with respect to x, which is going to give us just the constant a, and we're going to multiply those two results together. So I'm going to use a dot for multiplication here, and then the final result is going to be an times ax plus b to the power of n minus 1. So that's our derivative for that particular function. Let me just write it here a little bit more neater. So n minus 1. Now this gives us a clue as to what we need to do, right? Because we know, okay, so let's say we started off with this function. Let's just write it down here. We have an times ax plus b to the power of n minus 1. If we were to take this function and we integrate it, we would essentially just add 1 to the power, and we would divide the whole thing by an. So here we just have a times n, and we're going to add 1 to that power. So there are two operations being performed at the same time. So that means that we're going to end up with ax plus b to the power of n. Okay, so what does that tell us? Well, it tells us that if we now start off with this function and we want to integrate it again, then we're going to apply the same principle. We're going to take the function ax plus b, we're going to leave it the same, we're going to add 1 to the power n plus 1. And the next thing is we're going to divide the function by a, and we're going to multiply that a by the new power, which is n plus 1. Okay, so in doing so, what we're doing here is we're just adding 1 to the power, dividing by the new power times whatever constant is in front of x. So it's essentially very similar to what we were doing before with just single powers of x. So now we can write a general formula for the function ax plus b to the power of n. And we can simply say that if we know what the constants a and b are, we're going to have ax plus b to the power of n plus 1, and we're going to divide that by a times n plus 1 plus the constant c. So recall that the constant c is going to make sure that we account for any function that has this exact same derivative, no matter where it is shifted along the y-axis. So now what we can do with this is we can apply it to a bunch of examples. So let's start with a very simple one. Let's say we have the integral of 2x plus 3 to the power of 10. Now, at first glance, if you were to look at this function and you see a power of 10, then you might think this is a very complicated thing. In fact, you might think that what you need to do is expand this into the simplest, into individual terms, and then integrate each of them individually. But instead, we're going to just use this formula because we know this is in the general form of a binomial to some power. So here we're going to have 2x plus 3. Now we're going to increase that power by 1. That's going to become 11. And we're going to divide it by not only the new power, which is 11, but we're also going to multiply that by the constant, which is in front of x. And in this case, that's going to be 2. Okay, and then we just place a constant c over here. And now to finish that off, we're just going to simplify this expression. So we have 2x plus 3 to the power of 11. And that's going to be divided by 22 plus c. And now if we wanted to check whether that answer is correct or not, we can do what we always do with integrals. We can differentiate the final answer and see if we get back to the original function. So now let's apply the derivative to this whole thing. So let's write it down over here. d over dx of 2x plus 3 to the power of 11 divided by 22 plus c. And now we're going to apply the chain rule as we did at the beginning. We're going to start off by bringing the power down here. So that's 11 times 2x plus 3 to the power of 10. And now we still have this factor of 22 in the denominator. And now we're going to multiply that by the derivative of the inside of the brackets, which is just going to be 2. And the constant c, as before, is just going to become 0. So now when we multiply 2 times 11, that becomes 22. So these two terms are going to cancel out. And we're going to be left with 2x plus 3 to the power of 10, which is the same function we started off with. And that's how you apply integration to a binomial function to any power n. And in the next video, we're going to continue with some more examples. As always, if you enjoyed this video, make sure you hit the subscribe button if you would like to see more content from LetThereBeMath. I will see you guys in the next video.